Yeah, thank you so much for coming. Because I know that on pre-talks like the program, I said that like, oh, you don't need to have any experience in Rust. So just a sanity check, who actually have experience in Rust? You maybe put up your hand so I know how deep I have to go to or how, okay. Okay, so it's more like half and half, that's good. But don't worry, I expect nobody can write Rust, so like if you already know Rust, you may found it like, oh, like you can do it, yourself. That's great. You can maybe like kind of try something yourself. You don't have to follow everything because you know how to write the Rust code, and that's you can do a little bit more. But for people who doesn't write Rust, it's absolutely fine. You can follow. And also, I have put up the setup instructions before. I hope that people have already done it, but if not, like I would quickly show the steps that you have. So first of all, I hope you already have Rust installed on your computer, and also if you are using Windows, you may, because like I'm not using Windows, and someone told me that like, oh, if you're using Windows, writing Rust and then using Windows and compiling could be a little bit tricky. So yeah, I just don't know how to solve Windows problems, so I can't help you with that. I'm sorry. So without further ado, I'm Cheuk. I contribute to open source. I love open source. I love the community. I love Python community. I organize events. PyData London is, yesterday, if you have been to the lightning talk, it's happening in June. So that's also our 10 years anniversary. So, if you're into data science, you can come. And, there are also EuroPython, of course. This year, we're going back to Prague. And, that's great. I'm now serving the Python Software Foundation as a director, and right now I am a Python consultant. So yeah, happy to talk more about that, but let's jump into the workshop. So this is what you're supposed to have done beforehand. Install Rust, or if you have Rust installed before but you haven't used it for a while, update Rust. I'm going to use Python 3.12, and I think the setup today will be compatible with Python 3.8 or above. So I'm just recommending everybody to use the latest version of Python because, Python have a life cycle, and then after a few years, then, maybe Python 3.8 won't be, at the end of life and won't be support anymore. So keep updating your Python, please. So another thing, we'll use a virtual environment. You don't have to use PyEnv virtual env, which is my setup. You can use, if you have CPython, the standard will be .venv. You can use that. But again, like I just show you, I would just assume that you have some experience with Python and know how to do it with the tools that you're using. So I'm not going to go into detail like, oh, if I don't use PyEnv, how should I do it? I assume that you know your tool. Again, like Windows, I'm sorry. You can, because I will show you the repo, which like you can kind of, if you want to do the exercise again, or like, all the informations are there. So like, if you can't try it now, if like, oh, you don't want to like install a virtual machine right now, maybe you can try that at home. Right now, maybe share with your neighbors, or just like follow along. So, but again, like, I am trying to not spend time solving Windows problem. I'm so sorry. First of all, so assuming that you have done what I mentioned in the previous slides, the first thing is, set up your virtual environment and then install Maturin. So Maturin is the tools that we're going to be used a lot today. So what is Maturin? Actually, you will realize that we don't have to pip install PyO3. We actually pip install Maturin. So Maturin is a kind of a tool that we'll use to compile a Rust code, and then it will be packaged into a Python library. So that sounds like magic, right? So, but again, like if you know Rust, like Rust is a language that needs to be compiled, and then after the compilation, and actually like it will be something that like Maturin will make it into kind of like some extensions, some C extensions that you have, for example, NumPy, those kind of things that. So there would be a Python API, so you can use that in Python code, but it's a compiled executable file at the back of it. So that's how all the magic happened. But you don't have to worry about those. Like today, we're just going to be like, again, like the workshop is 101, so it's going to be a very brief and very like just like a taster of like using PyO3. So again, like a lot of deeper understanding. Of course, like if you want to use PyO3 for something that is like, in your production and stuff, you have to write Rust code and those. So again, like I'm not going to teach you Rust today. It's not the purpose of today. Today is to taste how to use PyO3, and then hope that if you found it interesting or something you want to do in the future, you can, find a path that you want to go. You can learn more, and then you can, learn Rust, and then kind of, make it into something that you could use at work, for example. So. So that's assuming that you have done the pip install, everything's good. So first thing, we will start a project. So Margarine is also come with a command that's called init. It will just create a whole project structure for you. So you can now do it. I would open a new directory. I call it PyO3 101. Like you can use the same name. Then it will be convenient because all the code just assume that you do the same. But feel free to do your own, but make sure that you know what you're doing. You have to kind of adopt it to your own version. So run this command, and then you will see what happened. So now I'm going to also show you what happened. So this is the repo that I prepared. Oh, OK. And I can't make the left-hand side bigger. I don't know how. Sorry. So, but don't worry. Again, this is actually on GitHub, so later you will see it. But what happened is that after you run that command, margarine init, you should be able to see that you would have some files that got set up for you. So first of all, there will be a cargo.toml file. So now you may inspect that file, so we just get a sense of what's going on and how things work. So cargo.toml file is, well, it's not pyproject.toml. We also see pyproject.toml. So we all know pyproject.toml file is for Python packages. But so cargo.toml is actually for Rust. So cargo in Rust is kind of like pip in Python, but not exactly the same. But again, I put it into easy to understand terms. Cargo can manage all your packages in Rust. So there's also this cargo.toml file that kind of describe the setup of this project. So you can see that package. So this is, now it's just default the version to be start with 0.1.0. Of course, when you're actually doing it in production, and then you're kind of, you have a second version, then it won't be 0.1.0. So you do semantic versioning. So you do you. And addition, again, the year is 2021 by default, but you can change it to 2024 if you want. But I'm not going to do that. Those are kind of not very important to make things work, so I'm going to skip over those. What important is this line, PyO3 0.20.0. So this is the PyO3 version that we're using. So actually, PyO3 is not a Python library. It's actually Cargo is getting it, so it's actually a Rust package. So the version we're using is 0.20.0. So this is, I think, is the latest version. And also you can see that there are some other information there as well. The library name, again, this will be the folder, the name of your folder. Again, you can use other name, but make sure that everything stay consistent. So also the crate type, you can see again, this is essential. Don't change it. So again, there'll be a lot of advanced detail and stuff, so I'm not going to go into it, but just don't change it, OK? You can change the name, but nothing else, please. Maybe the year and version, but nothing else, please. OK, so that's the cargo.toml. Just have a look. You won't have the cargo.log yet if you're just starting the project. So next thing you have is the pyproject.toml. So this is, I'm sure this is more familiar to you all. So this is information that PyPI will use when you publish your library. So of course, we are not going to publish it today. Otherwise, PyPI will be full of our trial today, which is not good. So we're just going to try it locally today. It requires Python 3.8. Again, if you develop it for, not supporting Python 3.8 or other requirements, you can change it. But again, today, I'm not going to dive into all the details of this, small things. We just want to have a taster and make it work, and then see how it works. So, okay, have a look at these two files. Any questions? 1 second, we're gonna give you a mic.
Bigger font, please.
Oh, bigger fonts. I can make this side bigger, but I don't know how to make the other side bigger. I'm sorry, but like you should be able to see in your directory. So this is like the. I'm just talking about there's 2 files that got generated. If you run Materin in it, you should have these 2 files. Not the log, cargo.toml and cargo and private.toml. Yeah, so that you have it. You're supposed to have it in your computer if you're following along. If you don't have, if you don't bring along your computer, it runs out of battery, or you're using Windows, you can't follow. Maybe ask your neighbor nicely, can they share it with you, and you can have a look. So yeah, so I haven't done anything yet. So we just type Materin in it, and this is generated for you. So, okay, all good. Any more questions? Except that it may be a bit small and difficult to see. Okay, good. So yeah, look at these 2 files. Just have a quick look, get a sense of how things work. Next things, for people who have no Rust experience, I'm going to just, explain it again. Like usually when I do workshops, I don't know how experienced people are. So if it's like very trivial for you, just bear with me. Just quickly explain this. So Python and Rust is very, very different. Okay. So Python, we never technically, I know that there is like some very niche project they can compile Python, but nobody actually doing that. So Python actually is a language that's supposed to be interpreted. So for example, so when you give your colleague a Python script, it won't work on their computer by default. They have to have a Python interpreter in their machine. So for example, everybody use CPython. It's a kind of standard distribution. You get it from PyPI, the Python.org, and then it's kind of standard version. You may use some other versions. There are other versions like, for example, some people use something that is like, because CPython actually interpret Python into C, which is another language, but some interpreter interpret Python into something else, like something that is like super popular in last few years is PyScript. Let's say PyScript actually interpret Python into WebAssembly, and then and then it's run on the browser. So that's how Python works. Python is super flexible. We don't have to really define the type of anything. Kind of, you sometimes feel like everything works with Python. So it's designed to be easy to use, to be like educational programming language to teach like younger people, for people who are not engineers to maybe able to use a little bit of scripting language to help their work. For example, that's why now we have like data science and other things. So Python is super flexible, but I know some people don't like it. That's why in the community now we have people start typing the Python code. So that's more kind of similar to how other language, for example, Rust, work. So Rust is kind of like C. It's kind of considered to be a lower level language. It needs to be compiled. So it will have a compiler. If you install Rust, follow the link that I've sent, that you have done, that you will already have a Rust compiler. So it's it's cargo. Yeah, everything is cargo in Rust, which is great. And also Rust is strongly typed, so you can't. So in Python, when you start a variable, you don't have to say what type of this variable is. But in Rust, you have to. Again, if you have never done any programming in C or something, you may find it a little bit different, but it's okay. We gotta get used to it. So other terms that use in Rust, we will have crates. Crates is actually it's very hard to find a Python comparison, again, because those 2 languages works very differently. So if I have to really quickly explain to someone who code in Python, it's kind of like, another Python file that you import into your other Python script. So, but it's not equivalent. I know you may be like, no, but I know Rust is not I know, but just put it simply. And again, we are not diving into the technical detail today. We're just trying to have the limited amount of time and get a taste of how things work. So if you want to study and understand Rust more, in the GitHub repo, I put the link to other learning resources that you can learn more if you want. But again, today we have limited time, so bear with me. There are also macros. We will come across some macros when we try to write some code today. So macros is kind of like I'm just quoting the Rust book. It's meta programming. So meta programming is like we would use some, for example, you'll see some macro that actually take a function and then it will generate some code that modify that function. So it's kind of like a decorator, but instead of doing it in runtime, it do it before, it would do it while the code get compiled. So again, if you only do Python, that may be a very new concept to you, but for people who have experience coding in other languages, that may be more familiar. So there are two types of macros, and I would dive into the detail after when we came across them. So again, macro is just some things to help your code to be shorter, so you can reuse the code, so you don't have to write the same thing every single time. So those are the good things, kind of like shortcuts for you to write good code. And I think Rust will do is panic. So I hope you don't panic when you see panic. So panic basically is something that goes wrong. There will be a failure message, and your program will get terminated. So that's panic. It happens at runtime. It won't happen in the compiling stage. In the compiling stage, you will get error message from your compiler. And one thing that I like about Rust is that the Rust compiler is very good at telling you what's going wrong. So it will give you a suggestion that this is how you can fix your code. And most of the time, if you follow the suggestion, it will work. So if you see an error message at the compiling stage, follow what you have been told, and you will probably be fine. So don't panic, OK? Right. So this is an example code that when you type muttering init, it got generated for you. So after you type muttering init, you will have a directory structure get built for you in your directory. From the src source directory inside, there's actually this script. It's already written for you. So before we write our own code, let's look at this example code to understand how things work. Then we can write our own code. So first thing, you can see that the first line, use PyO3 prelude star. So this is, again, in Python terms, for folks who only do Python, easy to understand, this is like an import. So if you're using things that's provided by PyO3, you will have to write this line. So again, don't change it. Keep it there. You will probably be fine, OK? So yeah, remember, it needs to be there. Next thing, these two are actually procedural macros. So what are they? Do they look like a decorator to you? It's kind of like something that you put in front of a function. Because the fn actually is like writing a function, right? So instead of def, you have fn, which is fine. Just change of characters. But these two procedural macros is kind of like a decorator. So what it does is that it will take the function that you're writing after as an input, and it will generate something to replace it and make it work, make it into a thing that would work with PyO3 and have your Python interface and your Python function can call it, OK? So that's why we need them. Again, I'm not going to dive into the detail. Just understand that we need these two to work. So first one, whenever you write a new function that is, and function that's included in your Python library, you have to put that in front. And then the key thing is that after you write that function, you have to put it into the Py module, because when you package the whole thing, then your module include those functions. So if you forget to put it in there, you will see the error message after if you don't put it in there. But today, everything you write, we will be writing as a Py function, and then after we write it, we'll put it into the PyO3 101 module there. Okay, but you will see how it works in a bit. Now it just sounds a bit kind of mystery, but it will be more clear when we do things. The next thing you'll see, I highlight this line because there's the wrap Py function exclamation mark there. So this looks like, oh, I'm just calling a function called wrap Py function, but there's an exclamation mark in the function name. What's that? That's actually not a function. It's another type of macro. Again, macro is just a way to modify your code. So instead of writing a lot of complicated things to include the summer string, that function, into your Python module, this gives you a shortcut to just write it as like a function. You know, when we write function, we reuse the code, right? We simplified it so we don't have to write the same code all the time. So it's kind of like that is for this macro. But again, like the difference is that, you know, technically macro is like it will do the modification, the code modification during compiling time. Function is like for one time. So, but for simplicity's sake, just treat it as if it's a function. Just remember that it's a macro, it's not a function. It's a little bit different, but we can use it kind of like a function today. Okay, so that's it. That's the thing. And then we just copy and paste this line over and over and change the name. So don't worry too much about the detail. Next thing is you can see that, again, like in Rust, everything needs to be typed. So this is kind of like what we do when we try to type things in Python. If you are already doing that in Python, this should look a little bit familiar with, like, for you. So yeah, so it's just remember that it's not optional in Rust. We have to do it. We have to decide on which type we want and stay there. Hopefully we'll have time to touch on the type conversion at the end. But again, like I will show you the repo. Every information is there. But again, like we have to type everything, including the return result, which is in our case, because we're using PyO3, we'll have the Py result, which is, again, provided by PyO3. Again, like for simplicity's sake, today everything is, you know, output will be a Py result. Is, you can see the first one is string. It could be something else, but everything is a Py result, okay? Next thing, why I have OK here? Why? So because Py result actually is a result. So in Rust, a common practice is that for each function at the end, it will return a result. It's either OK, so OK means everything is fine. And the other is, of course, everything is not fine, which is an error. So, in Rust, so at the end, it will return an OK or an error. So like that's why we have OK at the end. So in Rust, you can see that actually in Rust code, if there's no colon at the end, means that that is going to be returned. So at these two functions, at the end, it will return this OK object, right? Okay, it's a result object. So it's like, well, actually enum, but I'm just saying object for Python people. Okay, so yeah, so you will return an OK. So again, if you don't quite understand, just follow the pattern for now, and then you can study a little bit more after. So I'm highlighting this line again because there are some question mark at the end. So the first thing, you see the colon. So this is like kind of saying that the next line is another thing, you know, kind of like a line break, and also like this is not going to be returned. So there's a colon at the end. And then there's the question mark. So what are the question marks? So the question mark is kind of like a shorthand. So if, for example, the wrap py function somehow have an error there, and then it give an error at the end, so that error will get directly passed as a return, and then we just terminate it. We don't have to worry about what's come after that line. We just return an error and pass the error out. So that's the shorthand for the question mark. So you can see it as like, oh, it may or may not work. So that's why there's a question mark. So again, like I can't cover all the technical detail. Just remember this is what's going on here. Okay, so this is the example code. I hope it's not too scary. There are some familiar things in it. You know, if you write function in Python, you just like, you know, maybe you don't have the brackets. Just remember the brackets, remember the semicolons, and follow the pattern, and then you may be fine. Okay, for today at least. Today you'll be fine. I promise. Okay, so now we have looked at all the things that we got by default. Let's try to build it and see if this default thing that, like, you know, this function that was written for us, sum a string, if it works. So let's try that first. So we know how to try things out. So that's the process that we will do throughout the whole exercise and workshop. So if you type, so we're using Marturin, right? So well, we pip install it, we better use it, right? So muttering help and see what muttering can do for you. So if you type muttering help, you will see, so this is all the, like, it will be in your prompt. I know it's a bit small, just bear with me, like, or type it in your computer, muttering help, then you will see this on your computer. So you will see that we have a lot of commands. There's like multiple commands that you can build your package. You can build it and publish it, or just build it and like all this. But today, don't worry about it. We just use one. We just use develop. So what muttering develop this command, what this command do is it will take the code, the Rust code that you have written in that file, and then it will get a package, put it into a Python library, and install it in your virtual environment. So you can use it and test it out right away. So we're going to do that today. That's why it's very good to have a virtual environment, because you don't want it to be in your other projects. So have a new virtual environment for this development. So what you can do now is to type muttering develop. It will take a while to run because it's kind of packaging everything. It doesn't have any cache because it's brand new. And it gets installed in your, you become a local library, and it got installed in your virtual environment. So do that, and then after, when it's finished, you can type pip list. You'll see that you would have this like PyO3 101 thing that got like installed in your virtual environment. Okay, is everybody good? Follow? If you have questions, it's the time to ask. Or if you say like it doesn't make sense, it's too fast, then let me know. Okay, good.
So we should use the develop thing.
Yes, we will use develop today, because again, like other things, for example, publish, we are not going to upload it to PyPI. We are learning, so we are not going to do that. Yeah. All good? Okay. Good. Now is the time for you to shine, because now you have to write a Python script to try out this sum a string thing from your package. So I assume everybody is a Python programmer, and then you can do it yourself. Do you want to do it yourself, or do you want me to give you the code? No answer. So I assume you want to do it yourself. So try it out. And I can give you the code after as well, but first try it out. so like, yeah. It's boring when I feed you everything, right? So, you write your own Python script. Create a, like, I create a try.py. That's what I do. So you can create a try.py, and then write some Python script, import that library. So it's already installed. Muttering already installed it, pip install it to your local environment. So you can just import it, use it, try it, see if it works, see if you understand what's going on in the code. Oh, good. Yeah. Anybody is happy and like already tried it out and happy to move forward? Give me a thumbs up if you're happy to move forward. Okay, cool. Everybody, well done. You're a very good Python programmer. Okay, so if you're like, oh, I'm sorry, like I have some hiccup and I type a little bit slow, then don't worry, like I have the code and this is in the repo. You can just copy and paste after. So don't worry, like it's just a very simple Python script to test it out. So you don't have to learn it. You write better code than me, so forget about that. Okay, moved on. So next step, because that's actually the end of the slide deck. There isn't much in the slide deck. Everything is actually in that repo. So now, the most important thing, I don't know if it's big enough. Oh, it's too big. OK. Go to this repo, and all the information, exercise, everything I just explained is actually there. So if you have that repo, you can actually, like, for example, if you're watching online, if you have like somewhere to go, I don't know, or some work, email, meetings, you can actually go to that repo and then like you know, sayonara, like bye-bye. Like you can do it yourself. But for people who are sitting here and committed to the workshop, we will do it a little bit like, you know, we'll do it together and then we'll see how far it goes. If we run out of time, you can still do it at home. That's the good thing about it. That's why I put everything on the GitHub repo. So now you can go there, and so where we are is actually now we're just like get ready to start our first exercise, which is the Hello World exercise. So if you see the README, you can scroll to the you can skip everything and scroll to the Hello World. That's where we are right now. Okay. So if you want to, because again, like all the code, all the Rust code actually is, you know, is in the folders in that repo. So it's up to you. You don't have to clone. You can just copy and paste if you want, or if you just want to, like, you know, if you're super lazy, copy and paste is too much work for you. You can clone it and you can just run the script. So up to you. Yeah. So. Yeah, but I suggest you follow along and copy and paste, because like there are some steps that we're going like. So those scripts actually is like the final result at the end of each exercise. So there are some like intermediate step in between, which like you will miss out if you don't follow along. So yeah. Everything good? Everything got the link? Good? Okay. If not, just shout, no, stop. And then, but I would just assume everybody is good. So right now we would. So sorry about that. Like I know it's a bit hard to see, but again, like you have the GitHub repo. So if you can't see, go to the GitHub repo. So what we do is like we will do first exercise. So we'll go to the source and then the lib.rs, this file. So we are not going to create a new file. Technically you can, but again, like we are learning today and we're just like doing 101, just, you know, it's baby steps. So we're just writing everything in this file to make things much simpler. So now we are starting. So we will start to write our first ever function in Rust that will become a Python function. So what we'll do, we'll just do something very simple. We take a name as a string, and then we will just output a string saying hello. So again, like I'm terrible at typing, and you know I don't like live coding because I made a lot of typos and mistakes. So it's like your cooking show, you know, like, oh, instead of like chopping the tomato, it's already chopped, it's here, you know, that's what I'm going to do now. I'm going to copy and paste what I've done before. You can also do this, like copy and paste. So, or actually, I would go to, so I think what I would recommend you to do is, one sec, bear with me, go to the GitHub, like again, like this is super small, but don't worry, this is for me, this is not for you. You have it on your computer, I assume. So just copy this, you know, this is the function that we got to write, and I'm going to paste it there, and then you will see it at the end. So yeah, just paste it here. So this is our function. So very simple, you know, take a string. So again, like everything needs to be typed. So actually in Rust, there's more than one type of string, but again, just follow my code. We are not going to explain that because that would be a rabbit hole to dive into. But anyway, like you can read the Rust book if you want to learn all of those. So yes, question?
There is one question on Slido.
Yes.
Concerning the last example, are you required to write stub files to get type hints from compiled Rust modules? Some string seems to be typed as args any, quarks any.
Oh, is it like so is it for the library that you publish, like you want the type, like for example, you know, in Python, if you write in Python, right, you type hint it and then it will become a type, like, you know, the function will be type hint. Actually, this will be done for you. If you, well, you don't have an option, you have to type it because this is Rust, you have to type it. But after that, like, you know, when Maturin do the magic and like, you know, things like PyO3 and Maturin do the magic and then it become the you know, like for example, our case, like PyO3 101 library, inside it will be typed. You can actually change like the name of the variable and then like add more description and all this stuff using another macro. But I would talk a little bit about that in in this exercise. But right now, don't worry about it. You have to type it anyway. So just type it, and then actually it will be like your Python function will have that type as well. So it will be done for you for now. And then later you will see that we can use another macro to do some other magic, which yeah.
Thanks. The thing is, I just tried to clone this repo from GitHub, and after trying to type, how does it called, Maturin develop, I receive an error during the import of this model, which is input error. Dynamic model doesn't define model export function. Well,
you are one step ahead of everybody. Shh.
Okay. I'll just copy and paste it.
But you're doing the right thing. Trust me. I'm going to explain in a bit. Yeah. Okay. So yeah, you may be like copy and paste and try it out. Like I know you are so excited to try it out, but I'm going to explain it now. So again, like don't worry about this format exclamation mark. It's just like an F string. It's just the Rust version. Okay. So everything seems good, right? So now I can do Maturin develop, and it will work. Yay, isn't it? Okay, so let's try it out. So save, and then, what have I done? Okay, 1 second. Let me close this. Okay, right. So here I do Maturin develop. Right. Oops. What's going on? Okay, so so it complains that I'm using a snake case. Well, I'm a Pythonister, what are you gonna do? But anyway, that you should be able to see another error saying like it's a dead code somewhere. Yeah, function say hello is never used. So this is a dead code warning. It's because the thing is like warn dead code is on. So to make this warning go away, you can turn it off. So all these are actually warnings. So it doesn't hinder, you still have something that you can use, but now you can't use it because the say hello function is not put in the module. Remember, I said that every single function needs to be put in the module. We haven't done it yet. That's why it's good to leave this warning on. You can turn it off, but leave it on for today because we're a beginner. We want to learn it. So leave it on. It will remind you that you have to put your function in your module. Otherwise, it's a dead code. That function can never be used because we haven't put it in the module. So that's why we have that shout at your face. So let's fix it. Let's add it to our module. So what we're going to do is that, again, like follow the example. That's why it's good to have the example here. I love like what Maturin have done for us. I just copy and paste, and then I change this into say hello. So it should work if I change it, right? So okay, let's try it again. So and then do I do something silly? That's why I hate live coding. Yeah, because when I copy and paste, I delete the bracket. That's why it's like doing. Yeah. Okay. Yeah, there's always typo and stuff. Okay. Right. So now I only have the snake case warning, but I don't care about this right now. Like you may have to worry about that when you are writing a real thing. But again, we're just playing around now. So this warning, I'm just gonna ignore. I'm bad at naming things. I admit it. So what? So okay. So now this thing should work, right? So now I have a Python package that is badly named PyO3 101. Yeah, and also why is this capitalized? Maybe that's why it's not happy about it. Yeah. So. Yeah, now I have PyO3 101, and still not happy. Okay, whatever. It has a say hello function in it, and it should work, right? So let's try it out. So I should have a script like this. So yeah, it's saying hello. I use the say hello function. It's say hello to John. So it should say hello to John. So let's see if it works. So so Python. And then I put it in a directory. You can put it at the same working directory. It doesn't matter. So I quite try.py. Oh, error. What's going on? You see, that's why I hate live coding. It's like always something's going wrong. Yeah. That's not define module export function. Whoa. PyInit. Did I do something wrong with this? Trust me, it works when I was preparing it. Did you get the same error or not? Or is it just me?
I got the same error.
You get the same error. Okay, let me quickly fix that. I think it's just maybe some name thing and stuff.
I think it's because of the module name that you're using lowercase in your Python code, but it's uppercase the O in your.
Yeah, I don't know why it become uppercase. It's all lowercase.
Yeah, but in the RS, libRS, it's uppercase O. Down
Oh yeah, why? Okay, I don't know why. Like it may be because because I changed it halfway through when I developed the workshop. Sorry about that. My bad. Okay, it should be fine now. So let's do Material develop again. It compiles again and fix all the issues. Hopefully now we don't have warning. So sometimes the warning is actually good. You can't ignore it. Ignore the warning. You have the same consequences as me. Don't learn from me. But I'm giving a workshop. I don't know what I'm saying. Okay, so. Try again, so as if nothing happened, right? So now it works. They say, hello, John. Yay, I'm happy. Okay, do you get it? Do you get it? You get it? Fixed? Yeah, yay, good, well done. Okay, well done me. Right. Whew. Yeah, it's like again, like live coding usually become a joint effort. People help me to debug, so that's good. Okay, question?
There is one more question. I know Rust does not use object-oriented programming. It does not implement classes, but structs. Is it possible to export these structs to have them as classes in Python with methods?
Actually, there is a way to do it, but we are not going to cover it today. If you want to learn, you can go to PyO3, the user guide. It will explain how to do it. But again, that's more advanced topic. So today's 101. So that's more for maybe 102. Sorry, we are not going to cover that, but you can find the information on PyO3 user guide, which the link is provided in the end of the README, actually. So, yeah. Right, so I assume everybody is good. So let's move on to the next thing we want to do. So now you have successfully written a function using PyO3, so you have written Rust, yay! Okay, so it's a big step for a Pythonister who only do Python, that's good. Okay, so next thing we want to do is to try something else. So we have fixed the problem, the dead code problem, so what we're gonna do now is to try to see if we can make a default. So, oh, sorry, I jumped ahead. So now we're just saying hello, which is a bit boring, so how about we welcome John to PyCon DE. Shall we do that? Okay, so let's add another thing. So we add another variable or conference, so it's another string, right? Okay, so and then now I want to hello John, welcome to
Should be string.
yeah, typo. See, live coding. Welcome. Okay, welcome to what is the thing we want to welcome them to, and then I would put it in Python, and it will be the conf, right? So okay, I hope it's fine. So let's do it again. Oh, okay, I have to Material develop. Okay, no warning, which is good, or no error actually. Okay, so what we're gonna do now is let's say conf is PyCon DE, shall we? So okay. Oh, it should be a string. So now I kind of lose my skill to code in Python as well, which is bad. Okay, cool. So now let's try this script. So do a Python script running. Okay. Oh, welcome to PyCon DE. So yay. What about if the user, the Pythonista user, who is like, nah, I don't know which conference it is. Can you just give me a default in Python? You can have a default, right? In Python. Remember, we can just conf equals to something something, and then that would be the default. So can we do that in Rust and PyO3? So to make the default, we can't just do this like this. This is Python, right? So you can't do it here. No. So what you're gonna do is to use the function signature. So the function signature is also a way for you. There's actually another text function signature. Again, I'm not going to go through the detail. It's in the user guide that you can also change. For example, this is name here, but you want the Python one to not be name, maybe like username or something like that. Then you can change it there. But today what we're going to do is to create a default for it. So, so what I'm going to do is to add one line, add one macro, which you will see here. So this macro actually is defining what the signature for the Python function will be. So, so in the Python function, we will take a name and a conf, so two variables. And for the conf, the default value is the conference. So not toString right now. toString is just the new ones that Rust have because of different string type thing in Rust that I have to use toString to make it into the right type. But don't worry about it. Just copy and paste it. And but this is how you can change the signature from just name and conf to name and conf. The default value of conf is the conference. So this is how we do it. So now, if we save and develop again, so let me go to the terminal and develop. But, oh, I have something wrong. What have I done? Oh, did I miss a bracket? Maybe I missed a bracket. Ah, yeah. I deleted it by accident. Okay, so do it again. So that's why the compiler of Rust is really good. It just like tell you that something is wrong before you run the code because it's compiled and then like, you know. So I like it. Okay, so now it's installed, it's good. So now let's run a test code. So now what if I don't say conf? Will it give me the conference? So let's see. Let's run the code again. So let's go back to this. Oh, welcome to the conference. Oh, why there's a question mark at the end? I don't know what I'm doing. Sorry. I should delete the question mark. But anyway, welcome to the conference. Are you welcome? Yes, you are. So yeah. Anyway, so you get the idea, right? So now you have a default, and then you don't have to provide it in your Python function. You have a default value. So that's cool. Like now you can do some very, you know, Pythonistic stuff with this Rust code. So that's great. So we have tried those too. Another thing you can try, if you look at the documentation, the README, you will see that, oh, now we can also have a look. You can go to open a Python terminal and have a look at what, PyO3 has done for you. You will see that, import it and check. But because of the time, we have like less than an hour right now, and we have 2 more exercises. So I'm not going to do that. You can try it at home, or try. If you're very fast, you can try it now. But I'm gonna jump into exercise 2 right now. So if you're following along, we're now like at exercise 2. We're gonna try to read a file and see what happened. Okay. So now. Again, so what we're gonna do is to read the file. So in read the file, oh, very simple, right? I just copy and paste and add another function. Why it's not here? 1 second. Okay, copied and then paste. Okay, another function. But remember, in Python, right? If we use something that is not here, not in the not already included for you, you have to include it. So actually, we are doing something here. We are using file, something from the file crate, which we haven't included. So we have to include it. So we have to put in some extra lines at top. So we have to, so we're using the file and read, the IO read. So that's why we have to include those, because we are using some, like this one is from that. Question?
There's 2 questions in the chat.
Okay.
For the last section still. How difficult is it to debug the embedded Rust code inside a PyO3 library?
How difficult it is to debug. And again, like it depends on how familiar you are with Rust code, because like all these error that you saw is actually by the Rust compiler. So I would say that the Rust compiler is quite good at telling people what's wrong and the suggestion of how to fix it. But if you are like, oh, if I am completely new to Rust, it may be a bit scary for you. So again, like I think I mentioned it in the README, like if you want to use this in the future for real, learn Rust. I'm not going to lie to you that like, oh, you don't have to learn Rust and I can make everything work. No, because you're developing in Rust. Today I'm just gonna give you a taster, so like if this is something for you, you know where to find more information and learn it.
Okay, next question. Can I modify some string function to accept multiple types other than useSize, for example, a floating point number? Or
Yes.
do I need to write entirely new function?
For floating point numbers, like for different types, so again, exercise 1 and 2 will be just using string, but for exercise 3, we'll use different types. So again, like you are very smart and you are very ahead of everybody else. Shh. Okay.
Last question is it possible to pass dictionaries or lists to a Rust method?
Yes, again, like we will cover it in exercise 3. Thank you. Very smart. Everybody's so smart. I'm so happy. Okay, so right. So again, like we're using something that is like from file, from read. So that's why we have to include it. You know, again, all this. I'm not going to tell you everything. You know, if you write in Rust, you have to find this information yourself. They are all like online. You can easily find them. Like, oh, how to use this? Like file open, you will find it online. So we have this new function, and then we are taking 2 strings. So one is the file name, one is the name of the person you want to check whether they are in the registration. And then I would then open a file. So this is a buffer that actually, like, in Python, you also have that. You open the file, and then you and then you read line from that file or read from that file. So that's what it does. The thing that's different is that you have .expect here. This is how Rust work. This is basically saying that, like, if it doesn't work, so in Rust, you have to be very explicit about how error got handled. In Python, if you don't capture the exception, it will just like, error and then terminate, right? But in Rust, you have to be very explicit about what happened if something doesn't work at runtime. So for this case, if the file doesn't open or, you will see something, will demonstrate, like something goes wrong, it will just panic and say like, oh, no, I can't continue. This is actually good. That's why Rust is considered a very, a relatively secure programming language, because you can't access something that doesn't exist. So, yeah. So that's a good thing. That, like, if it doesn't exist or if something goes wrong, it panics and it just stop doing anything that may cause damage or security problems. There's a mule here. Again, this is something, again, if you know Rust, you do this. But if you don't know Rust, is a just mean that it's mutable in Rust. Not everything is mutable by default. In Python, it is. So you have to say it's mutable in Rust. So information for you if you're not familiar with Rust. Another thing is like the content. So this is we create an empty string. So it's a new string. It's empty. That we're gonna store the content in it. Again, we're gonna put the content inside, so it needs to be mutable. So the file, we gotta open it and do something with it. So mutable, and then content is the empty string, but we want to put something inside, so it's mutable. So after that, we would read. So we would put the things in content. So again, like, why there's an end mule here? Again, it will be another like whole day workshop to explain this. And this is and also this mule thing, by the way, is why people think Rust is so hard to write. So I'm not going to explain this. Otherwise, we will be here for the whole day. Just follow along if you're not familiar with Rust. If you want to learn why, I have the information for you. The Rust book, the reference is at the end section. You can find the link to study Rust. So you will know why there's the end mule there. But anyway, you have to put end mule here. So after that, the content will have the content of the file, and then it will check if it have the name of the person. Again, like there's an end there. Don't ask. Just because you have to. Okay, put it there. And then if the name is there, just give back. You are registered. Yay! I can check. I can find your name badge. Good. If not, then it's like, oh, sorry, you haven't registered. You can't come in. Please get a ticket. That. Okay. Good. So it all makes sense. So let's do it now. Oh, before that, of course, we have to edit here, right? We have to edit to the Py module, of course. So let's do it quickly. So that is check rec. So let's do that. Check rec. Okay. So right now, it should be doing something. So let's see. Oh, okay. Ooh, okay. Okay. Right, so we have some code. So now we want to run this to see if I can find join in rect_list.txt. Okay, so let's do that right now. So let's do, okay, exercise 2. Ooh, something's going wrong. What's going on? This is not expected because I forgot to develop. Sorry. So again, nothing happened. Okay, again. Oh, something goes wrong. Like, okay, look at the error message, right? We have a panic exception. Is a file not found? Of course, because if you look at our working directory, there's not rect_list.txt. It doesn't exist. So what happened is that, remember, I said that if, like, in the code, Rust will say, will panic, right? So here, if they can't find the file, it will panic. And then it does. And then because it's in Python, so when we run the try code, the try.py is in Python. So in Python, it automatically becomes a panic error. So if you look at the error message again, it's a panic exception. But if you I'm pretty sure you have done it before. Like in Python, if you read a file, you forgot to put the file there. It's not a panic exception. That doesn't exist in Python. It's a file not found error. So this is not good, right? If I'm like shipping this Python package and people, like, if they do something wrong and get this, like, this error message sucks. So how can we handle the error more elegantly, right? So PyO3 already know you will have this problem, so provide a way that you can do it. So what it does is that, again, like, I have to copy some code. So what it does is that you can define, like, you can put in a new exception for your Python. So in this PyO3 exception thing, inside, it will have a lot of different Python exception that you can use. So for example, file not found error. So this is just file not found error, so because it's Python exception. There are also other, like, the value error and other things, like, so. But again, like, you can find that in the user guide. Yeah, you have to include that, and then you can use it. So, but how do I add that in here? It kind of need to rewrite the code a little bit more. So again, like, I'm copy and pasting because I'm very bad at live coding. Oh, and yeah, and for people who are not familiar with Rust, this may be a little bit tricky for you, but I can explain it. So don't worry. So you can see that what changes is that instead of .panic, expect here, which would cause the panic, I would capture the result. So the file open will give me a result back. This is how Rust works. It will give you a result enum. So what I can do is to use something very Rust, which is matching, the pattern matching. So match, if it's OK, that means that it can find the file, everything is fine, then it will capture the file here. So remember, it was like let mule file equals to something something. So instead of doing that, I first capture the result, and then if it's OK, I unpack it here, and then I can do the same thing. So this is the same thing. All this inside in the middle are the same thing. Okay. So I do an extra step of checking the result. So this is the happy path. So what about the unhappy path, which is error? So if it's the error, I don't care what error it is, because I assume that, well, this is an example, so it's oversimplified. I just assume that, like, if anything goes wrong, it's because the file is not there. So I just float a PyO file not found error, and then I can even, like, put in the my own kind of warning, like, error message there. So so this is how you can change a panic exception into something that is more Pythonistic. So let's try this one. So shall we? So we can do develop. So it will, I do something wrong. Oh no. Oh yeah. Wait 1 second. What's going on here? Create a module. What Python? Use of undeclared create. Anybody smarter? Well, all of you are smarter than me, but, like, maybe some of you can spot it. Decorator missing. Yes, but sorry. Can you be more specific?
Yeah, the PyFunction decorator at the top of the function.
Oh yeah, this one. Yeah. Why is it not there? Oh, I made a mistake, probably. Okay, so Right. Yes. That's what I said. Everybody's smarter than me. That's good. Okay. So, yeah, I'm missing here. I have to fix this as well. Okay. So, yeah, I will fix it. I promise.
Now you remove the function.
Huh? Oh, yeah, the fn. Yeah, I'm so bad. Sorry. Oh, boss. Okay. Oh, okay. Whew. So, thank you for the live debugging. Okay, cool. So now let's try again, shall we? So let's try again. And now we have a file not found error. Like this is very Pythonistic. And then I have my own custom error message. Yay! So we did error right. So, which is a little bit oxymoron. That's great. Okay, so yeah, that's we have just tried the the unhappy path, right? That something goes wrong. So what if we have the file? So what you can do is to create that file that doesn't exist and try it. So I already have it here, actually, but the working directory is not correct. That's why it keeps missing the file. So what I can do is to go to that directory and then like do this again. And then it should work, because now I have the file and I have John in it, and then John is registered and welcome to PyCon, the conference. Okay, so yay! So that's exercise 2. So how much time we have? We have like around half an hour-ish. So last, we have exercise 3, which is the like handling different types, because so far we just use string, which is, it's not realistic, right? Like we have so many things in Python. We have lists, we have dictionary, we have floating points, we have like, the integer, whatever. Let's try them, not try them all, but try some of them here in exercise 3. So let's go to the exercise 3. So now we're here, checkpoint, like we're here, exercise 3. If you're following along, we're here. Okay, so yeah, we're talking about the type. So again, the nuance of two strings. So again, like you can check the information yourself. Now, we want to, let's say, do some numbers, right? Okay, so let's, put in a list and count how many items on the list. So this is what we're going to do here. Okay, so here now we have another function. This time, instead of string, we check in a vec of strings. So a vec is kind of like this. So if you are at the readme.file, you will see that I have a link to the conversion table that provided by the PyO3 documentation. So if you check, right, if you check there, so actually is here, user guide here, if you open it, it's a bit small. Let me zoom in. So you can see that, oh, I have a list. So what is a list? A list is actually a vec. But the difference here is that you can see the T here, which means that in Python, you just have a list and it could have anything in it. It could have different type of things in it. It doesn't work in Rust. Rust, it needs to be, well, there's a way of like creating something in Rust that have like different things in kind of like a chain kind of thing, but that's not what we are doing here. So for simplicity, we have to have a list that have every single thing in it is the same type. So this T is the type of that thing. For example, if we have a list of attendees name, then it will be a list of strings, right? So then we have a vec of strings. So that's what we are having here. And then I'm going to count how many attendees in the list. So it will become a integer. So integer is, whoa, what's going on here? There's so many integers. Yes, there's so many integers. So in Rust, there are different types of integers. There are I64, U64, usize. So I is, so let me think. I is the plus and minus, so we go positive, negative, so it's signed. U is unsigned, and so the number 64, 32 is how much memory you use for describing the integer. So the bigger the integer is, the more memory you're gonna use. So for example, like if you have a number that's like more than 255, you probably need something more than 8, right? And what is usize? Usize is like whatever the default in a machine it is. So again, like I'm not going to go into the nuance. You can read the Rust book if you want to understand all of these. But again, like just have a brief understanding of it. So So yeah, I'm using usize here for simplicity's sake. And then there's actually for the VAG, there's a default method .length, so it's kind of like Python, which is great. Question?
There's one question concerning the types. If
Yes.
it's possible to consume uncollected Python iterables in Rust.
What?
I guess iterators, generators. Is it possible to pass them to Rust?
I haven't thought about that, actually. Let me think. If it's a iterator should be a kind of, yeah, iterator is always, it doesn't have an equivalent. So, but an iterator actually is a, I forgot the Python term of that. Oh, jeez. Like, it's not a function, but like, but it would, jeez.
Generator?
A generator, yeah, like a generator. Is that a generator? Is that, these are actually Python native type. You have that, but maybe PyO3 provided that. There's like PyIterator, maybe PyO3 provided, but I haven't have a deep thought on it, so I don't want to answer that question because I don't want to give you wrong information. So sorry. Yeah, but that's a very good question. Like I have to try it out myself to give you a correct answer. Sorry. Yes.
There's two more questions that are very related. Like when would you go to Rust? So what are some of the operations that are worth converting to Rust?
It's a very good question. The benefit of using Rust is that because Rust is very good at doing concurrency. Python, we have like the GIL and everything is not very like multi-thread friendly. In Rust, there's less friction doing those things. So yeah, so there are some, again, like this is something that I can't simply give you a very like easy answer for that. But you may have to see what like the difference between Rust and Python. What Rust is known for is like very memory safe because of how they do the borrowing thing, those end thing, the borrowing and things like ownership that make like the Rust compiler is very robust and very strict on checking those. So that's relatively memory safe. And also, yeah, again, like Rust don't have the GIL and like you can easily do concurrency. So that may give you an idea, but again, like I don't have a very definite answer for that. Yeah. Okay. Sorry. Let's move on. So this is like okay. This is the method provided by VAG. It's kind of very similar to Python. Great. We love it. So let's add this and try. So remember to edit. Otherwise, you get another warning. So let's do that right now. And let's do that quickly. OK, so let's have a play. So in exercise 3, I should have it in the script. Here, it's not. No, I look at the wrong thing. OK. Yeah, so this thing should work, and the rest should not. So let me comment it out. This one also doesn't work because I will go back to the original directory. OK, so let's do that. So let's do a develop. So I go back to the original directory, do a develop, and then I run the try script. So Python 3 try. I have done something wrong. I have commented it out. I forgot to save. Sorry. Let's do it again. Right, so now it counts the list, and there's like 4. So 1, 2, 3, 4. Yeah, it's kind of worked as expected. So again, like it should be quite straightforward. And so let's do one more exercise. Yeah, we have quite a lot of time, so you're just like, yeah, good. I'm a bit worried about the time. So okay, so now let's read in a dictionary. So a dictionary, what is the equivalent in Rust? So the equivalent, according to this table, is where is it? Is a hash map. So a hash map is, you can see this. Oh, this is a bit weird. Why there's like this hash brown : : It's because again, like it's not by default there. We have to use it. you know, so it's from a crane called hash brown. So let's use that. So let's include that in the thing. So let me go back to my. Let's go back and then. Yeah, we are exercise free, and then we should be. Yeah, we have to include the hash map from the. Or there's like actually in the collection. So there's also some like standard collections in. It's kind of like our standard library. So there's a standard collection in Rust, so you can use that. There's the hash map there as well. You can use it, or you can use the hash brown library. I don't know the difference, but yeah, again, like you can look into the detail if you want. So, sorry, that's PyData London. Why? Why is it PyData London? There, 1 second. Okay, here. Right. So, so let's try. Yeah, let's do this hash map thing. So. I'm gonna put it here. Again, I'm not going to live code because I made tons of mistakes. I'm just gonna copy and paste. So you see, now we want to do a kind of more mathematical, like, you know, find average. So it won't be an integer. It will be a floating point. So if you look at, again, like, I'm not going to show it again, but like if you look at the table, you see that like, oh, again, like floating point, you also have like different size of floating point you can use. If it have more digit after the dot, then you may want, if you want it to be more precise, you may want to use a bigger memory for that. But like for this, I think 32 is more than enough. So F32, I'm using that. So the result, so the hash map. So hash map, this is like the key and the value in Python. So key, I'm using the name of the person, so that's the string. The value, it will be a floating point number. Because for the arithmetic, in Rust, I can't like I can't mix the different types, so it's not like Python again. Everything is so straight. So I'm using floating point for both the count and the sum. So it's here, and then remember it needs to be mule because I'm like adding them in. So here, for loop, you know, kind of like what Python is, and then add it in, and then just like, you know, do the floating point division here. And it should return the result. So it's quite straightforward, this one. So let's go back to my try script and then try this one. So I have attendees or string, and then this one. Python, like, I mean, in Rust you have to do this, but like Python, it will automatically convert it for you, so it should work. Yeah, so it's like this. So let's do develop again. And then, oh, I forgot to edit. That's what you get when you like forgot. So, yeah. I think after a while, then you kind of like it's muscle memory. You would always like remember to add that in. Yeah. Okay. Right. Okay. So let's try again. And. Now we have, it will calculate the average. So the average is the floating point number. And if you don't trust me, pull out a calculator and then calculate it yourself to see if it's correct, but it's correct. So that's all exercise. And now, at the end, I give you the freedom of trying different things. So for example, you want to try your iterator, you can try it now. But anyway, so like now it's like kind of like I always like doing like freestyle session at the end of the workshop, so people can like, you know, if you are a little bit like, oh, it takes time to catch up, you can now catch up. You know, again, follow the README. If you already very smart, I know all of you are very smart. A lot of you are very smart and like you're very fast. You can try something. You can try like all of the different type. Go to the table and try different type of things. Come up with, be creative, come up with something like to try. Can be very silly, it's a toy anyway, so, but yeah. And also Q&A time.
Yeah, I have tried something. I have tried to make a wheel file, but I have not succeeded in doing a wheel file which contains the compiled Rust code as well as the Python code from my package. So I actually want to have a wheel file which contains my Python code and the SO file, so I don't have to ship 2 wheel files.
That one I don't know. I don't know how to
Okay,
solve it.
thanks.
Sorry.
Other questions?
I realized that my IDE autocomplete is not working, and I just looked that the interface, Python interface files are not created by PyO3 right now. Is there like a workaround for that to get the autocomplete working?
That thing, I think there's have a look at the, because remember we used the signature, there's another thing called text signature that may be able to help you. So have a look at the text signature. If that one doesn't, then I don't know. Yeah.
Well, you partially already asked the similar question, but this one's going to be a bit different. So usually when people do some Python optimization, Python speedups, they try to speed up like a small part of their Python application, which is the crucial one. So I wanted to ask you, maybe you can name some examples, or is it usual for us to be just used to rewrite small parts of Python code? Just when people want to optimize something in their application and they have this model, which is called very frequently and it's very slow, and they just want to write that model in Rust. That is like usual part of it, or this thing with PyO3 is more popular to write libs and things like that?
I think like what you mentioned, I think there are other tools to do that already, like a lot of JIT compiler that you can use. For example, like NumPy is one that you could like maybe speed up some numeric calculations using NumPy. That is a JIT compiler, so it will like compile that part of the code, and then like that's exactly what you mentioned. So I don't see the reason of, unless you want to like publish this as a library and you want to write Rust, I don't see the, like for most people, I think the most direct way is to use those tools to like, to kind of speed up that part of Python. So yeah.
We had this need and we ended up using MyPyC.
Yeah. Yeah. But yeah.
Nobody knew Rust, so
yeah, so this is more for like people who kind of like, you know, either have experience in Rust or want to write in Rust, because, you know, for me, I think like, oh, I like writing Rust more than C. So yeah, so that would be, that would be like the way to go. But again, like for what you mentioned, I don't see the point of doing something completely new, because there's already other tools that's already doing that. You just need to purely written in Python, and like, you know.
maybe Rust is faster, I don't know.
Then you have to do some profiling and try it yourself. Yeah.
So my question is, so far we just wrote all the functions in one module.
Yes.
Right. So what if we want to modularize our package, like having multiple modules within that same module that we wrote in Rust? How do we do that?
Yes, that's a very good question. So for how to do that, you have, well, in Rust, of course, you can do that. You can actually, you know, have different, you can even have different crates and put it in there. So like, for example, in our code, these are different crates that is like, you know, written by different people. Like, so you can do that as well and have different file. And in real life situation, that would be what you do. You won't put everything into one file. But again, like, then you have to understand how to do that in Rust. So I would recommend you go to the Rust book. There's actually a chapter talk about how to like, you know, package different crates and like how to put them in. So like, yeah.
I understand the part of Rust. I'm talking about the part of the Python module. Like
Oh, this.
Yes, exactly. Yeah, that one.
So yeah, if, for example, so for example, this is on the other, you just like put this in like what you do with Rust. Like if you have this like travel average, then you just put it here. But then, of course, you put it somewhere else and then use, and then, yeah. Yeah.
Any other questions? There's one more in the chat. This is how to consume C-like data structures like a NumPy array from PyO3.
Again, like NumPy array is already quite optimized because it's written in C. And I don't think you can get a lot of speed advantage of rewritten every single, like the thing is already well written and proven in NumPy. I don't know how you're gonna, well, I mean, you can create a, kind of like pandas and polars, you can create a like Rust version of NumPy. But if you want to try to go like to easily get some speed advantage, I don't think that will be much different because both of them are, because NumPy is not written in pure Python, it's like already quite optimized, and you can try. I mean, like if you want to go through the endeavor and maybe create a library that is like much faster and safer, good. But it's not easy. Yeah.
All right, then I think this is it. Let's thank Cheuk again for the wonderful hands-on tutorial.
Thank you.